Another way of charging things is charging by induction, which can be thought of as meaning charging without actually touching. Charging by induction actually confuses a ton of students, and one of the things you just really need to understand is that the sequence of events, the order in which they happen, is very, very important. So, for example, I'll show you how to charge by induction two neutral metal spheres. One of the key things is that these spheres are actually touching each other. And I know at the beginning I said charging by induction assumes that there's no touching. And in this case, I guess what I mean, and maybe should have clarified, is that the charging by induction without touching means that we're not actually touching them with the charged object. The first thing that we do is we bring a charged object nearby. If I bring that balloon close to the spheres but not touching, it will actually polarize the spheres. Now the balloon, again, it drives electrons away. It's negatively charged, so that's going to cause electrons to flow through the metal. Now the metal conductors are touching, which means that they can share valence electrons. And so this balloon actually polarizes the spheres. It pushes the electrons away as far as they can possibly go. And the result is that those electrons had to come from somewhere. And they effectively, the electrons get rearranged so that on the part of the sphere close to the balloon, it's missing electrons, and that region actually becomes positively charged. Step 2 is to separate the spheres while the balloon is still there and while the charges are separated and the charges are distributed between the two spheres. Then in step 3, we remove the charged object. So I'm going to remove the balloon, and after that, each sphere has a net charge. Now, once we actually remove the charged object, the balloon no longer influences the spheres. So these charges on the spheres are actually going to rearrange themselves. The one on the left has a net positive charge, and those positive charges are going to be attracted to the negative charges on the other sphere. Or really what's going on is that the electrons, the extra electrons on the negative sphere on the right, end up being attracted to the net positive charge on the sphere on the left. So we end up with a distribution that looks like this. Each sphere is now charged. These spheres were initially neutral and touching, and it was bringing in the charged object and then removing them while they were polarized that ended up giving them each a net individual charge.